Hello, phenomenal ladies and gentlemen. It's Matthew Faro here again, and welcome back to my space. This is the first of hopefully a couple of videos in this playlist that I'm going to title the Virtual Series. I recently stumbled upon a problem set which apparently has been given as an assessment to some fresh college students after a couple of weeks of virtual classes. So I felt, well, let's make some fun videos out of these. Maybe it could help one or two of some people that are going to, watch this. Well, without wasting much time, let's get right into it. So let's get with the first question here. The first question here is talking about the composition of functions. So solution 1a. So the question says we should express f of x as a composition of two functions. So that means we want f of x to be equal to either p of q of x or q of p of x, where q of t has been given to us. Okay, so it means what we need is to actually look for a second function such that when we either precompose or postcompose with q, we are going to end up with f of x. So that is the mission. So we want to find p of x that satisfies that expression that we have there. So we have either f of x equals to p of q of x or f of x equals to q of p of x. This satisfies the above. So out of these two, I think one of them is straightforward. So I think the second one, so if we can find f of x such that, we can find p of x such that f of x is q of p of x. And what does this mean? If we expand these, f of x is given to us as square root of x cubed plus 1. And since q of t is the square root of t cubed, ordinarily we can evaluate q at different points. We can find q of 1, for instance, that is square root of 1 cubed. We can find q of a, and that would be square root of a cubed. So what is q of p of x? That is simply square root of p of x cubed. And looking at both sides, we can see that there is square root on both sides. We need to get p of x. So what we do is we find the square of both sides. So square of both sides, let's write it properly. Taking the squares of both sides, we obtain, let's write it out, x cubed plus 1 squared equals the square root of p of x cubed squared. So in this case, the squares cancel out, and we're left with x cubed plus 1 equals to p of x cubed. So how do we treat situations like this where we're looking for p of x, or when you're looking for an unknown that is cubed? So for instance, if I have 27 equals to x cubed, what do? We take the cube root of both sides. So it's the cube root of 27 equals to the cube root of x cubed, and the cube root of x cubed is just x. So if we do the same thing, so we take the cube root of both sides, and we obtain p of x is equal to the cubed root of x cubed plus 1. We are done, because that is our objective. We wanted to find p of x. So it means f of x is actually equal to p of, or what did we do? Q of p of x, where q of x is as given, square root of x cubed, and p of x is what we got. Cubed root of x cubed plus 1. We could actually check if this is correct. So let's find the composition itself. So what is q of p of x? So if this is our q of x, then q of p of x is square root of p of x cubed. And that is equal to the square root of the cubed root of x cubed plus 1 cubed. And in this case, the cube cancels the cube root, and we are left with square root of x cubed plus 1, which is what we're looking for. Well, that is the easier way out, but the other side, we could also find f of x as composition of p and q in this way. How do we do that? So first and foremost, we can observe, so this is an alternative solution. We can observe that we want to get square root of x cubed plus 1. And we know that if we take the q of t and we square it, or let's take q of x squared, that will give us x cubed. So because that is square root of x cubed, then we square it. So if we square this, you get x cubed. So this is something that is in the f of x that we want to get. So this is in f of x. So what else do we need? We need plus 1 and a square root. So we know that if we do q of x squared plus 1 and we take the square root, that will give us f of x. So why not do p of x equal to square root of t squared or x squared plus 1. We know that if we do square root of x squared plus 1 as our p of x, if we compose this with q of x, if we bring in q of x and replace x with it, we are going to get f of x. And that is exactly what composition is. So it means that if we do p of q of x, that is square root of q of x squared plus 1, which is equal to the square root of, so what is q of x again? Square root of x cubed squared plus 1, which is equals to square root of x cubed plus 1. So again, we can write f of x to be the composition of p and q of x. Don't mind my mixture of notation for composition. So composition can be written in this way, and it can also be written in this way. So that answers the question. So the first one is writing f of x as q of p of x, where q of x is as given and p of x is what we derived. And the second case is writing f of x as p composed with q of x, where p of x is actually this guy, square root of x squared plus 1. All right, so I think that is long enough for one video. I'm going to stop it here, and by the time we come back, we come and start with the 1b, which is about domain and range of a function. Until then, enjoy mathematics at its peak. Bye.